Hi guys, today we are solving this sum called majority element, and this has been also frequently asked in interviews. So let's read it. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 number of times. You may assume that the majority element always exists in an array. The example states that the given array is 3, 2, 3. So we return 3, which means 3 occurs majority number of times, that is more than n by 2 number of times. So here n, that is the length of the array, is 3, and n by 2, that becomes 1. So 3 occurs more than one number of times, that is 3 occurs 2 times. So that is why we return 3. In the second example, the array is 2, 2, 1, 1, 1, 2, 2. So when we analyze this array, we see 1 occurs 3 number of times and 2 occurs 4 number of times. And the length of this array is 7. So 7 by 2 becomes 3. So 2 occurs 4 times, that is 3, more than 3 times. That is more than n by 2 times. That is why we return 2. This could be simply solved just by having a sort function, arrays.sort. This is the brute force approach. And then simply return nums of num dot length by 2. So here what exactly we are doing is we are sorting the array, and then whichever element is present at n by 2th location would be the majority element, because as stated, the majority element occurs more than n by 2 number of times. That means the element should be present even before that, after sorting. So let's see if this runs. Let's try to submit this. But as we can see here, we have a follow-up that we have to solve this problem in linear time and O of 1 space. That means we will have to solve this problem using another approach. That was a brute force approach, but if we just that in the interviews, that won't be enough. So we go on with another approach, which is either by using hash map. So there is one more algorithm, which is something that you cannot come up with, which you need to know beforehand. And it is called Murray's voting algorithm. So in that algorithm, what we're going to do is we're going to have a variable called count and a variable called candidate. Let's initialize these two with 0. After that, what we're going to do is we're going to have int n iterating through the whole array. And after that, if count is initialized as 0, then we simply make candidate as n. If that is not the case, then what we're going to do is we are going to have count plus equals to n equal to candidate. If n is equals to candidate, then we add 1 to the count, or we subtract 1. After that, we just simply return candidate. Let's see if this runs, and then I'll explain it better. Yes, so this runs. As we can see, this is done in O of n time complexity and O of 1 space complexity. If we would have used a map or hash set or any other, then that wouldn't have been an O of 1 space complexity approach. So this is what they are exactly asking for in the question. So what we are doing here is we are iterating through the whole array, and we are checking that if the count is 0, then we are making candidate as n. Otherwise, we are adding 1 to the sum, or if the previous element was also, that means if previous element or candidate element was the same. If that is not the case, then we subtract 1 from that. And that is how we are taking count into account. And if we want to see what is the output of count, we can simply do this. Let's see what do we get. count will become 0 a number of times, and just by that we understand that this is not a very simple approach to come up with, and that is why you need to know it from beforehand. So this is for the previous. Let's just do one thing to separate these two. Yeah, let's run it now. This is for the first array, that is 3, 2, 3. Let's take a dry run. While we are iterating through nums, our count is initially 0. We come up with 3, which is at the first location. We make candidate as 3. Then we move forward. Our count is 0. But now as we encountered 3, what we're going to do is we're going to add 1 to the count. So our count becomes 1. And that is what we are printing here. After that, we encounter 2, which is not equals to 3. So what we're going to do is we're going to subtract 1 from count. So count becomes 0. After that, count becomes 0, and then we have to reinitialize candidate as n. So now the third element that we encounter is 3. So that becomes candidate, and we increment count, which is 1. And then we simply return candidate, which is 3. Our output is 3. Now, coming to the second test case, we encounter 1 at first, we encounter 2 at first location. Our count is 0 because that is how we started, and we initialize candidate as 2, and our count becomes 1, as you can see here. The second element is also 2. So we again keep candidate as 2, and count becomes 2 because 2 has occurred twice now. Then we encounter 1. 1 is encountered, so we decrement count. So it becomes 1 again. And then again we encounter 1. Then we decrement it again. Then we again encounter 1. Then we decrement it again. So our count is again 0. After then encountering 2, we get to know that our count was 1 because we encountered twice 1 and twice 2s, and then again we encountered 1. So our candidate then becomes 1, and our count becomes 0. After that we encounter 2, and then we decrement it, then again our count becomes 0, and then we again encounter 2. As count was 0, then candidate becomes 2, and that is what we're going to return here, and this is what is the output. I know it is a bit tricky to understand, but once you do some dry runs, you will understand it better. Let's try to run it now and submit it. Yes, so our sum is done. I hope you guys understood. I'll see you again tomorrow. Thank you.